Hello there, I'm Thomas. This is a German-American pilot flying the Boeing 787-900 in tonight's flight from Zurich International Airport. And we will flying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 1449. Let's localize the landing surrounding the cockpit for the pre-takeoff preparation of the quality wings Boeing 787 900 jet aircraft. I'm gonna start the quality wings and Microsoft Flight Simulator X. I'm gonna start showing you the cockpit instruments and displays and the functions of the Boeing 787-900 jet aircraft. I'm gonna start with the primary flight display. Now displays the airspeed indicator, the airspeed selected from the autopilot, the flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands of feet per minute, or the steepness of the trigonometric angles in degrees and can climb and descend. We have also the altitude indicator with the pitch ladder in degrees and the bank angle in degrees, the Lszh localizer, horizontal localizer, and the vertical glide slope for guidance to the airport runway for landing. So we have the horizontal and vertical instrument landing system glide slope and the Lszh localizer crossbars for this guidance, and the magnetic north pole heading of the runway we're gonna use for landing, takeoff and landing. So we have also the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the, as I told you, the angle of attack of the aircraft as it flies, the standby instrument display, the integrated display with the flight plan, and the HSI, the horizontal situation indicator. You can see in the primary flight display over here. We have also the flight mode and zero with the autopilot and the autothrottle, later in vertical navigation modes. So we have also the navigation display. The navigation display that displays the GPS position of the aircraft, the terrain and weather reflections from the weather radar. We have the terrain map with the airports where they are located. You can see the terrain around you, how far away the airports are located, your own airport, and the runways we use for takeoff and for landing. We have the VOR aids, the nav aids, the VOR stations, the ADFs, the NDBs, and also the waypoints. The waypoints include horizontal and vertical navigation fixes for the aircraft to fly through using the flight plan we have already created. You saw in the flight management computer. I just show you how to create a flight plan using all the data of the aircraft for this flight. So also in the navigation display, we have the vertical profile of the aircraft for climb and descent, and the terrain in the vertical profile. You can see over here we have the horizontal profile of the navigation display and the vertical profile of the navigation display. You can see the flight plan with this purple line from takeoff, climb, cruise, descent, approach, and landing. Also here is the climb. You can see also the cruise and the descent part of your flight plan. So we have a complete flight plan or route or flight path for the aircraft to fly. So we created using the flight management computer. Also in the navigation display, we have the magnetic heading and track, and the magnetic north pole and the true north pole, and magnetic variation depending on where we are in the world. We have also the you can see other aircraft that fly around you using the transponder, the ADSP and ADSC transmitter receiver that transmits our own frequency to other aircraft, and the air traffic control, and also receives from other aircraft, and it generates the TAKEOFF system, the traffic collision and advisory system. The warnings, you can see the other aircraft displayed with a cross, with a diamond shape. You can see the altitude difference of the other aircraft, the distance they are located from you, the closing in speed, the velocity closing in between the two aircraft, and also whether they climb or descend. And you can see also the warnings from the TAKEOFF system if you need to avoid a collision. So we have this instrument to help us see the other aircraft in the air as we fly, or in the ground, in the terrain. So we have also, as I told you, the flight plan. I use the flight management computer over here. So you can see this is the flight management computer. I created a flight plan. You can see here is the flaps we're gonna use for takeoff. Over here the trim with the center of gravity and the takeoff speed, V1, we rotate V2. the route, departure and arrival, airport. Over here we select departures, arrivals, and the fixes we needed. Here is the legs. The first leg after takeoff, second, third, the waypoints we have, and here's the 6,000 feet. You can see also the altitude constraints. So we have over here is the top of climb, somewhere around here, flight level 21, the Nigra waypoint, and then we have the top of descent. We're descending back to the airport. You can see the waypoints we have to transverse, the runway 14 over here. So I input the gross weight of the aircraft somewhere around here, the fuel on board also. So I'm gonna show you now. I will give you the explanation about all the systems of the aircraft. Before doing the flight, we're gonna make a complete flight from takeoff, climb, cruises, and approach and landing in the end part of the video. So stay with me until the end part of the video. So I input all the data of the aircraft for this flight, and includes also I input all the data of this aircraft for this flight. That includes the gross weight, the takeoff gross weight. That includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing fuel tank, the center tank, and also other calculations about the treat fuel and the reserve fuel. Also, this using the flight management computer, this calculates automatically the mean aerodynamic chord position of the forward wings, the center of gravity. Using the center of gravity of the aircraft, this generates the load and the fuel on board. It generates the center of gravity position in respect to the Mach, the mean aerodynamic chord of the forward wings. I will explain also that. So the Mach is the 23% of the forward wings position. For this percentage of the forward wings chord position is the position where the maximum aerodynamic lift is being generated, and is the position where the stall begins for a given angle of attack as the aircraft flies. So we have to pay attention to that as we fly. Is the position where the maximum aerodynamic lift occurs in the top surface of the wings, and also we calculate the center of pressure behind that, and also this is used for the center of gravity and the calculation of the horizontal tail trim stabilizer position. So we also trim the horizontal tail of the aircraft in terms of this mean aerodynamic chord of the forward wings and the center of gravity, to balance the aircraft in flight, using also the vectors, the thrust from the engine. So this gives the flight altitude of the aircraft as we fly. So I'm gonna show you also that from the outside view. So we input all this data. The flaps we're gonna use for takeoff, 15 degrees of flaps, that increase the lift of the wings and allows the aircraft to fly in lower airspeed also, and with the landing gear extended. So we have also we select the runway we're gonna use for takeoff. So we have selected the runway 14 in the Zurich International Airport, the Lszh in the Switzerland. I have selected this airport for this flight for takeoff and then for approach and landing. So we're gonna depart and arrive the same airport and the same runway 14 in the Lszh Zurich International Airport. So I selected the runway length, the runway slope, the runway conditions, if it is size, dry or wet, the wind direction and speed, the barometric pressure and the density of the air and the temperature of the air. And this calculates with all the aforementioned data that I have already input into the flight management computer. It generates the takeoff speed, the V1, V rotate, and the V2, which is the flight speed after rotation, after takeoff. So we have the V2 plus 15 knots, which is gonna be like 150 knots for this flight, with 15 degrees of flaps. It's gonna be our climb speed for the initial climb. We have selected also the flight plan or flight path or route of this aircraft for this flight. So we're selecting the departure and arrival runway. Also, I have inserted the seats, the standard instrument, departures, waypoints, and fixes that include horizontal, vertical navigation fixes for the initial climb of the aircraft from this airport. I have also selected um, the top of climb and the intermediate waypoints and fixes for the cruise. After the initial climb, we have climb to the cruise level. The cruise like 35,300 feet, then 29,000 feet. We're gonna climb higher. So then after we have the top of descent, and then we're gonna start the descent, commence the descent into the back into the airport. Long final and short final navigation fixes. We have the stars, the star terminal arrival waypoints and fixes for the arrival to the airport. Is gonna help us guide the aircraft with the runway to align them. So we're gonna have also the Lszh localizer we have selected automatically, so the frequency of the Lszh localizer, the instrument landing system of the runway, we have selected the runway 14 of the Zurich International Airport. We're going to have the Lszh localizer, the horizontal localizer and the vertical glide slope, and the Lszh localizer crossbars are going to help us guide the aircraft with the magnetic north pole heading of this runway for landing. So we're going to make a successful approach in the vertical glide slope profile with the horizontal localizer and with full alignment. So I'm going to show you the manual guidance for approach and landing. I'm going to use also manual thrust perhaps, or the auto throttle, so you're going to see also that. I will explain you all the systems before takeoff. I will make an engine start demonstration, and then we're going to make a complete flight from takeoff, climb, cruises, and approach and landing. So we have the flight plan or flight path or route for takeoff, climb, cruises, and approach and landing. Also, this gives information to the autopilot and flight director system panel for navigation. We have the LNAV and the VNAV. I'll explain you later the autopilot and flight director system and the auto throttle. So using the flight management computer, the data for the flight plan, the aircraft is going to calculate the climb, the cruise, descent, approach, landing, and the airspeed. If we need to use the autopilot automatically, and it's going to follow the flight path or the route or the flight plan. Purple magenta line using the navigation display. So I will show you now the flight controls, how to control the flight controls of the aircraft. I have the side stick here to show you a control the horizontal tail of the aircraft for climb and descent, also the trim of the horizontal tail position. I will show you also that the trim tab, how I balance the aircraft in flight. So I will show you how to control the elevator, the horizontal tail elevator section for climb and descent using the control column for climb or descent, and also the ailerons and the spoilers for bank roll turns, making left and right bank roll turns, and also the rudder, the vertical tail, the rudder using the rudder pedals, and also we have the rudder pedals for nose steering and parking brakes. So I will start now, perhaps showing the flight controls as I told you of the aircraft. I'm gonna be very brief in this flight with the explanations, so I'm gonna start now. Maybe so I'm gonna start now over here showing you the flight controls of the aircraft. So you can see here we have the side stick. You can see we can climb and we can descend over here, make turns to the left and turns to the right like this. So you can see the side stick deflection is proportional over here to the yoke deflection. You can see how it moves. Also the rudder pedals if we need. You can also use only the yoke like this. This is descent, climb. You can see also this view over here. So this is the side stick deflection. Here is proportional to the yoke deflection. Hope you can see that. You can make turns left, turns right, and climb. Also descent, maybe better view from this side. Also using the thrust levers like this. You can see the thrust over here moving up and down. So this actuates the engine power. So you have also the horizontal trim stabilizer here, the autopilot disconnect if you need, like in the Airbus. So we have other functions also. So you can see, make turns left, make turns right. You can see both sides are moving together, are interconnected, the captain and the first officer. The flight controls, the yoke of the Boeing 787, the control wheel and the control column, and also the rudder pedals are moved together simultaneously. Side stick deflection proportional to the yoke deflection. So also maybe I will show you now the outside view of using the flight controls. One more time, you will see the flight controls, the ailerons and spoilers, the elevator and the rudder from the exterior view. So you will have a better idea of how the side stick is used, or the control yoke of the Boeing 787, control column and control wheel, and the rudder pedals function. So again, as you see here, inside and outside also. Γιατί?
Γιατί έτσι κλείνει το χαρτί για να πάμε.
Μα να κάτσουν να τελειώσουν την πτήση μέχρι τις...
Σε πόσο? Πολύ γρήγορα.
Κάτσε, περίμενε.
Τώρα ξανά σου πάσει μία ώρα. Μην μου ξεκινάς τα δικά σου που το έχεις κάνει. Σε πόση ώρα?
Περίμενε γιατί...
Πώς, είναι τα και 10, πώς μου.
Γίνεται μέχρι τις 12 παρά 10.
Γιατί τόσο πολύ, μου πες μία ώρα πριν. Πιο γρήγορα μπορεί να το μοντάρεις.
Κάτσε, περίμενε λίγο
να
να...
ραντεβού, πιο γρήγορα μπορεί εσύ.
Να το σκεφτώ λίγο. Τι ώρα πρέπει να φύγεις?
12 παρατέταρτο που έχουμε βγει από εδώ.
Θα το προσπαθήσω μέχρι 12.
Τι να προσπαθήσεις, βλάκα. Θα στο κόψω εκείνη τη στιγμή, πες μου να ξέρω, θα το κάνεις ή όχι.
Θα προσπαθήσω να το έχω τελειώσει πιο γρήγορα, αυτό θέλω να σου πω.
Ωραία, θα δίνω μετά αυτά.
Ναι.
Δες τον χρόνο, γιατί κοιτά, βγαίνω και πρέπει να είσαι και έτοιμος.
12 παρατέταρτο, εντάξει. So we're gonna have the explanations about the flight, about the flight controls, as you can see. So you can see here the flight controls for the aircraft. Make the rudder, left and right turns, climb and descent, so this is the general explanation of the flight controls, as you can see. So we go now with the rest of the systems. We're gonna make a very fast explanation of everything about the autopilot flight director system panel, the thrust levers, the overhead panel. We're gonna make an engine start demonstration. Also, to start the engines using the APU, the auxiliary power unit. It's gonna provide the electric and air pressure for starting the engines, and then we're gonna make a complete flight from takeoff, climb, cruises, and approach and landing using the Boeing 787-900. So we're gonna have all the systems now, the explanation, the autopilot flight director system panel, over here, as you can see. So we make everything very quickly right now. We have the auto throttle left and right here, as you can see. Flight director on and off. LNAV and VNAV. So we're gonna leave maybe the LNAV. We're gonna have LNAV autopilot disengage like this. The bank angle, the heading select. I'm gonna select the heading and the airspeed. You can see the airspeed guidance, the heading guidance, magnetic north pole heading, and the vertical speed. We're gonna descend if we need, level off or climb automatically. So we're gonna climb 3,500 feet per minute. Now we're gonna select the altitude, first thousands of feet, then hundreds. So we're gonna have full explanation. We have the auto throttle over here. You can see the auto throttle. We have the disconnect switch for the pit stream. Here you can see the alternate pit stream, and this guarded switch is the cutoff switch for the pit stream stabilizer of the horizontal tail. So you have the horizontal tail here, and you need to disconnect from the automatic to the manual. So you can use this switch here to trim. You can use this switch to disconnect the autopilot if you need, perhaps this, or no, it's in the other side. So we have it here, the flaps position, extend and retract like this, the fuel control left and right, the parking brakes, the fire extinguishers for the left and the right engine, the fuel flow, the auto throttle, disconnect switch. This is the thrust levers. You move the thrust levers forward and after and activate the engine power, and the thrust reverse like this. You engage the reverse. As you can see the engine here, the indications, the reverse. So you can see the reverse now is open like this, or closed. So this is how you use the reverse very quickly. And we have a few more things to do before going to flight. I will show you also. We have the indications of the engine. We have the landing gear here, extend and retract, the alternate gear, the lock override, the auto brakes here, maximum and rejected takeoff. You can see the indications from the engines. Also here we have the N1, which is low speed and low the indications of the engines. We have the General Electric GNX engines installed in our Boeing 787-900 jet aircraft. Jet engines, we have the indications. The N1, which is the low speed starter SAP, low pressure compressor and turbine of the turbofan, which is engine, the exhaust gas temperature per engine. The N2, which is the high speed starter SAP, the high pressure compressor turbine of the turbofan, which is engine, the fuel flow per engine per hour, 1,000 kilograms, 1,000 pounds, oil pressure, oil temperature, polarity, and the vibration of the N2 stage of the engine. We have also the pressure from the engines, the pressurizer from the 5th and the 9th stage, and from the bleeder from the bypasser from the fan stage. So this we need pressurizer from the engines for hydraulic fluid tanks pressurization, wing energy, gas, air conditioning and ventilation, and also for the cabin pressurization with climate descent. The FADEX are the full authorities electronic control computers, one installed per engine gearbox, controls monitors and displays all the data and the engine indication you see in the display. That I just explained you. Also engine start, engine shut down, the fuel flow to the engine, fuel metering unit, fuel heat exchange sensors, and the pressure inside the engine. We have an overpressure or under pressure. You can open and close the outflow valve, the two lower high pressure settings to relieve the pressure or increase it. We have also, as we climb and descend, as we climb from the sea level up to 20,000, 30 or 40,000 feet above the sea level, like 10,000, 11 or 12,000 meters above the sea level. As we climb higher, the air pressure, the intensity, and the oxygen level becomes less than half of that of the sea level. Also, the aircraft flies with an airspeed rate about 2 or 3 times faster than that of the sea level. So as we climb higher, we have a different fuel mixer request every second to the engines, because there is a difference of airflow into the engines from the front fan states for compressor and then for fuel mixer. And this is adjusted by the FAREX automatically every second, so it's a good thing to have the FAREX installed into your aircraft. So now I'll show you now the overhead panel. I will go to the engine start demonstration very quickly. So you see, as I told you, this is the horizontal trim stabilizer. Then we go in the overhead panel. We're gonna make you can see the left and the right generators from the engine, the battery. This is the electric section. So we start the APU. The primary flight control computers need to be in the auto position. The heading reference, the RS initial reference system, the flight control surfaces, some other systems here, the window sheet, the rammer turbine, the hydraulics, the left and right engine hydraulic pumps. You can see here. We turn off all of them. You will see fault messages generator like this. So we turn back on. Left and right, and electric C1 and C2, the rammer turbine. You can see also we have the lighting of the aircraft and the windshield wipers, some other systems. After the electric and the hydraulic, we have the fuel system here, the left and the right wing fuel tanks, the crossfeed valves, the fuel booster pumps over here. As you can see, fuel booster pumps. So you can press this out and then press them in. And the balance, we need crossfeed off right now. So we have the wing and engine RDIs over here, all on because it's ice. And we have the electronic, we have the fuel jettison. You can dump some fuel here, select the fuel to remain. Electronic engine control for the engines with the auto start, left and right auto start. You can see the engines here. And the pressurizer from the left and right engine, and also the cabin pressurization over here, and also the pressurizer. You use the upflow valves for climb and descent, and also you need when you have most of the time in the auto position. So we have a couple more things. We have the display over here of the systems, as you can see. That is showing the overhead panel. Now we have the systems, hydraulic, APUs running, the oxygen, liquid cooling, the electric, left and right engine, the APUs running, the battery voltage here, main battery and APU battery. As you can see, the hydraulics, left and right engine, the C1, C2 electric, set of valves, 5000 psi left and right engine, the sender also, where the hydraulic fluid goes, which systems use hydraulic fluid, the fuel on board, left and right wing fuel tanks, center tank, the crossfeed valve is all, but you can feed either engine. You see left and right engine with either tank or either pump. The APU is fed from the left wing using the DC motor. You can see we have 11,000. 11,000 is balanced between the left and right wing. Center tank 12,000, total 34,000. You can see the high pressure fuel valves to the engines are running, and you can see the minimum fuel temperature below which the fuel we freeze over here, and the temperature of the fuel right now. So we heat the fuel in flight all the time using the recirculation into the engine. The air inside the cockpit and the cabin, the pressurized air, the doors are closed, the cabin can be pressurized, the landing gear here. You can see the temperature of the brakes and the pressure of the tires. Flight controls, very important. You can see the flight controls movement here when you move the yoke of the rudder pedals, the tail, and the position, the stabilizer over here of the horizontal tail. So you see everything here is working well. There's no malfunction of hydraulic systems. For instance, the FE's maintenance, security breaker again. So we go here, we have one last thing, the checklist, normal menu, just like in the Boeing 777, communication, navigation display again. So we go into the start the engines very quickly. So we start off both engines here, both start off, cut off the fuel control. So you will see now we're gonna have the messages, the resets here, and you can see the N1, the exhaust gas temperature all decreasing. So this will make the engines of the Boeing 787 come to stop. You can see also the hydraulics are having no pressure. So we're gonna start the auto start here. You can see these switches. We need to get them to the start position, as you can see. So we have the auto start now on. You can see the resets and the overhead panel with yellow, and also we're gonna have pressurized air from the APU being automated very quickly. So we have high pressure, now 20% of the N2, 21.8, and we can see the spinning of the right and the left engine. So we can initiate now the fuel flow. We let the fuel control here, both left and right engine. So you can see the running. Now we have running fuel to the engines, and you can see the auto start is kicking in, 36%. Fuel pump, we're gonna have exhaust gas temperature. So you can see both engines are running now. The auto start is kicking in, keeps building pressure, both left and right engine. So we have running engines right now. The engine start is complete, and we can now proceed for takeoff. So I take the runway clearance for takeoff, and so we have now the complete flight. Stay with me until the end part of the video. You're gonna see the takeoff, bank routes, and approach and landing. So thank you very much. I'm Thomas, as is American Pilot flying the Boeing 787. So we proceed now with the takeoff. Disarm the parking brakes. Advance the thrust. Not so much thrust, perhaps. So we need to come to the runway. Is the tiller for alignment, as you can see. So we have maximum takeoff thrust. The runway is open for us. We take the clearance for takeoff from this runway, from the air traffic control, and we align the aircraft, as you can see. For takeoff. So we are ready here. So disarm the auto throttle and advance the takeoff, full takeoff power, and disarm the flight director actually. So we have the full takeoff power right now, and we are proceeding for takeoff, as you can see. So we have 130 V1, we rotate, and V2, and we take off. The takeoff rotation, landing gear retract. We have positive rate of climb, as you can see. So this is the initial climb of the aircraft. And we have like I believe 30 more minutes for this video to end. So you can see the indications over here. So you can see the terrain also. You can see we are 2,000 feet above the ground level, but 4,000 above the sea level. So there is a difference. The airspeed 250 knots. We climb with 5,400 feet per minute. You can see the trend lines and the flight plan here. We have to follow the vertical, also the terrain below you, the indications from the engines, and we keep climbing. So this is the initial climb of the Boeing. So we need to start also gonna make a turn right now. As you can see, we got side view, and we need to make a turn to the first waypoint as we climb. So we're gonna use the flight plan here. So you see, I'm just flying the Boeing 787 like this. So we keep climbing over here. And also we need maybe I use also this view as we're climbing. And we're gonna have also this here. You can see the exterior of the Boeing 787. I'm gonna turn here. So we have the Boeing 787. Keep climbing over here, following all the waypoints, the fixes. So we have about 15 more minutes for approach and landing. So we need to keep going. So you can see we make a turn right now. So keep climbing a little bit. We use also the LNAV if we need on navigation over here. Okay. Cross this waypoint, keep climbing. So you can see we're keep climbing here and we're flying manually. You can see we have the legs here, the Germany, the Bayern Munich, and the France. On this side, the galaxy, the galactic, beautiful galactic view over here. And the Switzerland, beautiful Switzerland, and the Italy behind us. So fine. Also the lakes here, beautiful mountain lakes, and some other aircraft are coming. Okay. So you see the other aircraft. We have flight crew. So this is a very beautiful view over here as we keep flying, and you can see this way is France, this way Italy, Switzerland here, and the Germany in front of us. So we have very beautiful views over here, the Boeing 787. And the lake here again. So hope you like the views also, and navigation. We have about 12 more minutes to go for landing. So keep climbing over here. As you can see, 12 more minutes approximately. So we're gonna cross 23,000, 35. So we need to start maybe making the turn now. So we're gonna make a turn now, turn back to the airport. As you can see, we have to follow the waypoints. So when you see it, the turn. And also the engine thrust like this. To make this turn coordinated. So you can see we are in a bank roll right now. And we have very close the Bayern Munich this side, the Germany, and the France from behind us, and the lakes, the Switzerland and the Italy on this side. So make the turn. We have to follow this waypoint here, flight point. And we keep climbing, and we have a few more minutes left to go, like 10 more minutes for the video to end. So we have here my own navigation, keep going, 35, and we keep climbing now, 39,000. feet over here, and we need to increase the airspeed also. So we'll increase the airspeed now. As you can see, the flaps retract slowly, and we follow here. So this very beautiful view, and we have like 9 more minutes, as you can see, to fly manually. $37,000 feet navigation. Over here now we're going perhaps back to the airport. So you can see we can climb over here. So we are very closer now to the airport. You can see we have this beautiful star sign and the vapors from the frozen vapors, as you can see. So you can see the France on this side, perhaps over here. The lake again behind us, very beautiful views. So now we're gonna fly almost with a much higher airspeed. We need also to descend, start the descent. So we have reached the top of climb. Maybe connect the autopilot just if we need. Connect the autopilot, and then we start the descent. So we have 5 perhaps more minutes. So we need to start descent and vertical speed, decrease the airspeed also. And the vertical rate of descent right now. It's gonna be like this. So we're gonna descend now. So we have the autopilot connected, as you can see, AP on over here, and we commence the descent, the autopilot on, and we need a few more minutes to go, like I don't know, maybe 6 more minutes. So we descend. You can also disconnect the autopilot, and we use some speed brakes here to increase the rate of descent. We can disconnect the autopilot and follow again the manual flight path over here if we better like. So keep descending and having nicer views over here as we descend. $30,000 descending, you can see. So we need to switch a little bit the approach profile. Gonna make small. So keep descending. $14,000. Make a small turn. Goes faster. $13,000. First and second waypoint now over here. So we're gonna have a lower airspeed set here. For landing and then for approach. Keep descending 10,000 feet. Need to start our turn now to the runway. $7,000. Keep approaching, and we need a couple more minutes. We are in a very good position, so extend a few more flaps, and we need a little bit more airspeed, and landing gear maybe down. So we are here, you can see, approaching, full landing. So we're gonna have this view here for the landing. So we need a couple more minutes. Extend a little bit more flaps. You can see also the ILS localizer, the capsule that we have over here, the airspeed, the altitude, the rate of descent, and the barometric altitude. So we need those a director. So we are in approach for landing. So we capture now the ILS localizer here. As you can see, just capture it. You can see also we fly with manual flight controls, keep flying the aircraft for the approach. Add a little bit more thrust, as you can see, and balance the aircraft. So we have some side wind, we need to balance the aircraft with the flight controls, with the yoke, make turns with the ailerons, spoilers, add some airspeed also. So we have a little few more seconds for the approach and landing. As you can see, flying manually here, approach and landing. I'll do more thrust. And need to increase the rate of descent, align with the rudder pedals and the yoke, the ailerons and the spoilers, and also a little bit less power now. And we're very close for here for the flare. So we are approaching the runway. We're gonna flare the aircraft for the touchdown. So we need to align, and here is the flare. Very beautiful touchdown, as you can see. So thrust reverse, idle thrust and thrust reverse, and parking brakes also. So parking brakes also applied, so we slow down the aircraft, you can see. Very beautiful approach and landing, touchdown, as you can see. So we keep slowing down the aircraft, and we have full slow down. You can see the aircraft is starting up the way it should be. All landing gear here. You can see the nose wheel of the aircraft is perfectly safe. There is no breakage of the nose wheel, the landing gear behind it, all the tires. There is no breakage of the metal parts of the landing gear. Everything is safe, and the aircraft stands. As you can see, the nose wheel here also, the front wheel. No breakages from the landing. We made a very good, very safe landing. You can see how we landed. Also, we made a very aligned landing, very straight line with the center line. So we look back inside. We need to cancel the thrust reverse. So you see the reversers deployed like this, and then cancel. So this is the thrust reverse again. We use it to slow down. So you can see everything in the cockpit is perfectly safe again. There's no we can do another flight if we need the same aircraft. So that was Thomas Hatsios, the German-American pilot flying the Boeing 787-900 nice flight from Zurich International Airport back to Zurich International Airport. We just landed very nicely and back into the airport after completing a flight from takeoff, climb, cruises and approach and landing. Thank you very much for watching one more time. See you next time. Bye.